Hi everyone, this is the problem of the week solution video for the problem ladder. As usual, let's read through the problem description and then we can go over an example solution in Python. So the description goes as follows. You are attempting to climb up the roof to fix some leaks and have to go by a ladder. The ladder needs to reach to the top of the wall, which is h centimeters high, and in order to be steady enough for you to climb it, the ladder can be at an angle of at most v degrees from the ground. How long does the ladder have to be? And for our input, the input consists of a single line containing two integers h and v, with meanings as described above. You may assume that 1 is less than or equal to h is less than or equal to 10,000, and that 1 is less than or equal to v is less than or equal to 89. Which is very good because we would not have a triangle if v was not between 1 and 89. One more thing is, let's keep in mind that v is in degrees for later. As for our output, it's expected that we give a single line containing the minimum possible length of the ladder in centimeters, rounded up to the nearest integer. This is also very important, so let's keep that in mind when we're going over our example solution code as well. Looking at our outputs here, it seems that h and v are separated using a space. This will be useful for parsing our inputs. Alright, so that was the problem. So just from reading the problem, it feels like some elements from geometry class are going to have to be used to solve this. Sometimes it's helpful for me to draw it out. So let's open up MS Paint and see what we need to do. My apologies in advance for the bad quality because I'm drawing this using a mouse. So getting out the right triangle tool, let's sketch this problem out. So in this case, we have our wall as one of our legs. So that's going to be this leg right here. With the height of this wall as our variable h. So let me write that down here. Our angle is formed by the intersection of this bottom leg, which is probably the ground, with our hypotenuse. And that's going to be represented by our variable v. And so that's our measure of the angle there. And we're trying to solve for the ladder length, which is going to be the length of our hypotenuse. Let's call that x for now. So if you recall from math class in right angle trigonometry, the sine of an angle compares the opposite side with the hypotenuse. So we can evaluate this using the formula sine of v equals h over x. So that's our opposite over our hypotenuse. Rearranging this equation such that we're solving for x. So let's get x on one side. We get x equals h divided by sine of v. And this is basically the equation we're going to use to calculate that length of the ladder. So let's head back to our code. First thing we do in our code is to import the math module. This is part of Python's standard library, so you shouldn't need to install it beforehand. Next thing we do is to get our input and split it by a space to get our two individual numbers. So keep in mind the input returns a string, which is why we need to cast it to an integer later on. In line 6 and 7, we're then picking off each of these variables from our original string. So our length is the first number, and our angle is the second number. Indices start at 0, so that's why the number are 1 off. And we cast them to an integer so we can work with them later on. So next, we get to the part we were talking about before in MS Paint. We want to figure out how long the ladder has to be. So we'll be using our formula here. X equals h over sine v, but we will substitute our variables in to get this value. So in this code, just for clarity purposes, I made h equal to length and v equal angle, but in line 10, this is the same value as that formula we were talking about. So our length divided by the sine of our angle. It's important to note that the math.sine function takes in radians. So we'll turn our angle, which is degrees, into radians using the math.radians function. You could do this by multiplying by pi over 180 as well, but math.radians is a little bit more compact for this code. So just make sure that everything's in radians for your math.sine. Our last step is to just print everything out. One more thing though, in our problem it was mentioned that we should round up to the next integer. So we do that using the math.ceil function, so that'll just cut off the end of the number and round it up. That gives us our final answer, and we print it out right here. So let's go over the example test cases that they gave. 570 should return 533. And so that's one test case done. And our last test case is 1010. We expect this to return 5759, which it does. So as you can see here, our program successfully accomplishes this task. And that'll be it for this video. If you guys have any questions, email or remind is probably the way to ask. And I'll see everyone.